Well, hello there, 3390 folks. This is the first lecture, we'll call it. And in this brief video, I'm going to cover two things. The first thing is I want to walk you through the mess that I've created on Moodle for the site for the course. And then the second thing is I want to talk more broadly about what to pick for your thing that you're going to use as the subject of all of the work you'll do in this course. So let's get started by having a look at the Moodle site. So here you've got the Moodle site that I've created. I'm looking at it as hopefully you see it. I just posted, the link for the Zoom meeting. So I'm going to keep that as a static Zoom meeting. So basically on the times that we decide, that's the link to go to. Because it's a freebie, free Zoom account that I have, our times will be 45 minutes. Now, one trick to know is that if we need to talk more, or if you want to talk more, then we just close out that first Zoom meeting and start up again in the same spot. So you go back to the same link and the timer starts again. So that should be pretty straightforward. I hope that'll work. I'm pretty sure that'll work. The other thing is, as I said somewhere, maybe in the syllabus, that I'm going to record these sessions. Now, I don't feel comfortable recording the sessions without your okay, but I'm only posting them on the Moodle site, and the intent is to give you a place where you can go and catch up or see what answer I gave or what answer someone else gave without having to go anywhere else. So I hope that you'll be okay with that. If you do have any concerns about it, please express them to me. If you don't feel comfortable expressing them in the class, then just send me an email with your issues about why you wouldn't want it to be recorded. I've never recorded stuff in class videos before, so this is a new thing. I think you want it. If you don't, again, say so. I'm doing this for making your life easier. Now, the other thing that I've got here, so that'll be static. There's announcements. When I want to ping stuff out to you, I'll use that. If you want to ask me questions or whatever, then hopefully you'll do them in class. Or you, I hope, will go to this general Q&A. And if you go to the Q&A, you should be able to add a discussion topic. Like I've starred this one, which came about because of a question from one of you the first couple of days of the class, which was, which CAD software? Now you see I put in a pretty lengthy explanation there, and I hope that that is satisfactory. I spent a lot of time thinking about this CAD software question. It's been a perennial question every time I've taught a course, whether a first year course or a later year course that uses CAD. People always want their own favorite package. So I have reasons why we're using SolidWorks, and for simulation we're using ANSYS Workbench. And I can tell you more stories about what people in practice have been saying about that decision. It's kind of interesting. So the place where you'll find the weekly, essentially the lectures, is in this first block. And if you go down to the corner here, you should find that if you click that, you go to YouTube, and I've got a playlist there. And my playlist will have sequentially in order the videos that I expect you to watch for class. So that should be pretty straightforward. So that will again be a static link. That's where you go to look for stuff. The syllabus, which you definitely want to have a look at because it's got the details. Open it in Word. I put it in there as a Word document. I put in there the syllabus in a form that has lots of detail. And I didn't do that for legalistic reasons or whatever. I did that because this becomes our contract for what I will follow as much as possible to the letter, if I can, the policies about the assignments, the grading, and the course. So you'll see that I've got a weekly plan here for what we're going to be doing. And I've even laid out or got some links for the software we'll be using. And somewhere, yes, I laid out on this page basically what the projects are. So the assignments are already there. I'm not adding anything to those assignments in a sense. That's complete. I'm using this as the overarching guide for what my expectation is from you and the grading that I'm going to be doing. So those are the assignments already there. So definitely go through that syllabus carefully and ask questions about it. I've put in the schedule for the course, which would be when the projects are due. The first project will be due February 7th, and that's a set of CAD models, an assembly of the thing that you're going to use as the subject for this course. Now, you'll see that there's really only 3 deliverables. There's 3 projects that I'm looking for you to supply for grades. There's also your weekly contribution in class of asking questions and answering questions, and that's ongoing. But there's only those 3 touch points where I'm looking for you to deliver something to me. So that's good in some ways, but it's also bad because if you think that the night before those are due, that's when you finally get down to work in this course, no, that would be really unfortunate. What you should be doing is following along the videos as they come out, and you'll see that each video is fairly active and asking you to do something. Well, the right approach to this is to take the videos, particularly the early CAD videos, as a challenge to, CAD along with Andy. Some of you already have really good CAD skills. Some of you are not as strong as you should be. I hope by the end of the first month of this course that you'll all be at some decent functional level with designing stuff using CAD. That's the intent of the course. So it's not something that you can just turn to your friend and say, what do I do here? You really do need to play around with it and struggle with it. The thing about SolidWorks and every other CAD package, there's about a dozen different ways to model something, probably more than that. And so you need to come up with the ways that work for you, and you'll use them again and again. So, welcome the struggle. Hard to say that. Yeah, it will get better as you go along. So what I'm asking of you is that with the videos where I'm going step by step, showing you how to do something, try doing it. You'll see the videos, the first block of them in CAD are about building a birdhouse or modeling a birdhouse. And so, make one. Make one different from mine, but follow the same steps. And then once you've had that experience as you're going along, and it will go fairly quickly, then use that in designing and modeling your own thing. And if you can do that, if you can follow along with me in the videos, and then you can take the same or similar activities to make your own thing, then you're going to be good. Well, you're already good, but you're going to be good at CAD. So that's kind of my plan. Now you'll find the lectures, certainly in that playlist over here. You'll also find them in this Moodle book, which really just goes to the same links. Oh, there's a cute picture. And this is really just the links that are already there in the playlist. So you can find things here. It's exactly the same links to the same playlist as you'll find at this point. So suit yourself how you get that. I will be adding the weekly or the multiple whatever vlogs that I'm doing for the course to this playlist. So there will be a chronologic order to it as we go along. So project one. Project one is a CAD model of a multi-part thing. What is that? What I say in the rules, both in the syllabus and just copied right here, is that your model will be at least 5 separate parts. So it's not just a single blob. It's a thing made of multi parts, because that's a skill and that's a common thing. And those parts I'm expecting them to be challenging for you. You pick the challenge, because the more challenging thing you pick, probably the better grade you're going to get, because it's really going to tax your skills. If you're someone who is already a CAD wizard with SolidWorks, then pick something really hard. Pick something with surface modeling and whatever. Pick something hard. And then you'll be maybe surprised to find that I actually know how to use CAD. And I can probably help you through most problems you'll encounter, because I've encountered them myself. I'm not like some of your professors who will just tell you stuff but not actually know how to do it. I do this stuff. So pick something hard, and I'm there to backstop you and help you out. So what I'd like to do at this point, and I've got a few more minutes left in this video, is talk about the thing you're going to pick. As I've said, it's a multi-part thing, 5 parts, and I'm looking for you to pick something that's interesting and challenging for a couple of reasons. One is it will really expand your abilities if you pick something that's difficult to model. If it's something that's for your team design project in your main design course, then that's even better, because you were going to do that anyway. You're just going to do it better and with help from me. So pick something hard. Now the third thing, and again, the reason for picking something challenging, is that you live in a world where finding a job is different than it was even a couple of years ago. When I talk to recruiters at any of the big companies, and I do, and engineers, one of the things that people say is that, resumes are really kind of dumb, that we don't learn much about people from resumes. What we really want to know for an engineer that we might hire is, what can you actually do for us? And the best way to show someone who might consider hiring you what you can do is show them what you've done. And that means you have to have something that you can show. Well, a portfolio, a professional portfolio, is something that architects have been building up for decades in their practice. But it's something that is new and coming into it more and more with companies, where they want to see examples of your cool work. Well, if you pick something for this course that you can create a CAD model for that's really challenging and really unique and really cool, and it stretches your ability with CAD, then you're going to have something really cool to put in that portfolio. So when Tesla or SpaceX or pick whatever company you're interested in working for comes looking for someone to fill a design job, then you're going to have something really cool to show them, to convince them that you're the person that they want, and that's worth it. So pick something you're interested in, pick something that is worthy of your time. Now what you're going to do with that is, first of all, you're going to use that as the subject of that first project to assignment, which is you're ultimately going to, after a month or so, submit that to me for a grade. So it will have at least 5 parts, and it will be challenging, and you'll do an awesome job of modeling it. Once we're done the first solid model part of it, because this course is not just about creating a solid model virtually, it's also about engineering it, in a sense of connecting that with reality. So we're going to do two things with that model. If you want, if it's appropriate, we're going to select one or two or a couple of pieces of it, whatever seems to make sense. And you're going to manufacture those either through 3D printing or laser cutting, so that you can build a mock-up of it to see how it works. And then if that is successful, and you'll do some iterations of the model based upon that, then you're going to want to do an analysis of it. Now, we'll be talking a lot in the second half of this course about something called finite element analysis, FEA. And that is the basis of what, if you go and do a simulation in SolidWorks, a simple simulation, it's doing a finite element analysis of your model. And if you've played with that at all, you know that you can do a flow analysis, you can do a heat analysis, you can do a stress analysis. Those are all using these things called finite elements. We're going to talk about what that actually is. But then you're going to use your model as the thing that we will analyze. We're not going to use necessarily the SolidWorks FEA tool, because it's basically a simple version where you can run it without knowing anything, and that means you get results that you don't understand, nor that you can control. We're actually going to use an industry standard package that you can get a free student version of called ANSYS Workbench. ANSYS Workbench gives you control of the meshing, which is dividing the model up into little elements, and gives you control over a lot of the tools that you need to make a valid finite element model. So you're going to be using that, and you're going to be using the CAD model as the starting point for that. So at each step along the way with the first project, if you pick a thing that you don't model very well, for instance, you need to do it better. Or if you pick a thing that, for whatever reason is inappropriate for 3D printing ultimately, or inappropriate for finite element analysis in the way that you've done it, then you're going to have to backtrack and sort that out. So thinking ahead, the sorts of things that you may want to consider is, well, for instance, here's a model of a diagnostic reader that I've been working on for quite a while, and this is just, I think, 3 parts of it, and the CAD model that I've printed, it opens and closes like it was intended. I needed this model to see if the cartridge that we were designing would fit in here appropriately. I was looking at some of the features, kept looking to see if you can see it inside the device, trying to see, this has can't quite get it off. This has a shell on this side, in which there's an electronics board. And so building the model allowed me to see physically, is this going to work? Now, we moved on from this to a different design, but having the model you can handle is quite useful. Then taking that, and in this case, there's a hinge, and seeing, well, what's the stress, what's the flexibility of that hinge? That is the subject of what we can do in finite element analysis. Likewise, this device has in it a small heating element, and we needed to know how quickly will the heating element heat up, and what level of temperature gradient can we expect. Well, we could do that in finite element analysis, but only after we'd built the model. So FEA doesn't design things for you. It gives you ways to evaluate or analyze the designs that you had in your mind. So that's where we're going with this. The first step is to become more capable and just awesome at doing SolidWorks for product design. And then moving on from there and getting a handle on turning that product into reality and seeing how it works out. And then finally doing some simulation and analysis of the product. So this is going to be a hands-on course. It even says so in the course description. Hands-on the computer. And I think you're going to get a lot out of it. So with that, I'll stop this video. Thanks a lot for watching. Let me know what you're thinking, and we'll talk in the live sessions, and you'll be seeing lots more videos like this. So thanks. See you in class in a live Q&A later on this morning, I guess.